On the morning of June 3rd, 1998, a German family was enjoying coffee while traveling on a high-speed train. This train was on its way from Munich to Hamburg. It was 10:30 a.m. and everything seemed normal. But just 12 minutes later, that same family was terrified when a piece of steel suddenly ripped through the floor, right between their seats. And that was only the beginning of the deadliest accident in the history of German high-speed trains. In the late 1950s, Japan shocked the world when the Shinkansen, the world's first bullet train, was launched. It connected cities at incredible speeds and turned long journeys into short ones. Inspired by Japan, France and Italy built their own high-speed networks, and Germany soon joined them. Germany launched its own project called ICE, Intercity Express. When these trains arrived in the 1980s, the world believed they were the future. They had aerodynamic designs, modern computer systems, and unmatched comfort. Everything seemed perfect. But behind this perfect system was a hidden flaw: the wheels. The first-generation ICE trains were built with monoblock wheels, single-piece solid steel wheels that were strong, cheap, and reliable. But after some years, passengers complained about strange vibrations at high speed. In the buffet car, glasses, spoons, and plates rattled because of the vibrations. Engineers inspected the trains and discovered the problem. Although monoblock wheels are balanced from all sides, if even 5 grams of extra weight develops on one side, the wheel becomes unbalanced at high RPM, creating vibrations throughout the train. Friction from high-speed travel caused uneven wear on these wheels, disturbing their balance. At slow speed, it wasn't noticeable, but at 250 kilometers per hour, the entire train vibrated. Balancing a car wheel is easy, but balancing dozens of massive train wheels, each made from a single steel block, is extremely difficult and expensive to replace. So German engineers came up with a new solution: resilient wheels. These wheels were not one piece. The inner ring and outer ring were separate pieces with a rubber layer between them. The rubber would absorb vibrations, and when the outer tire wore out, only that part needed to be replaced, not the entire wheel. This design was already being used in trams. But there was a problem. Trams run at 30 kilometers per hour. ICE trains run at 250 kilometers per hour. The stress was completely different, but nobody paid attention. Executives approved the resilient wheels without proper testing, and by 1992, all high-speed ICE trains were fitted with them. For a few years, everything seemed fine. But in 1997, Hanover's tram company, Östra, discovered cracks in their resilient wheels. They replaced the cracked parts and warned Deutsche Bahn, Germany's national railway company. But since ICE trains had not reported vibrations, Deutsche Bahn ignored the warning. Exactly 1 year later, on June 3rd, 1998, everything changed. At 10:30 a.m., ICE train 884 left Hanover for Hamburg. It had 14 coaches, 2 power cars and 12 passenger cars. On board were 287 passengers and 8 crew members. In Coach 1, George Dittmann was traveling with his family, enjoying the journey. Minutes later, something hit the floor from beneath, and a sharp steel fragment tore through the floor between their seats. It was a piece of the wheel. George and his family panicked. If that steel piece had struck even a few inches left or right, his family might not have survived. He quickly moved his wife and children to the next compartment and went to find the conductor. The conductor was in Coach 3. George explained everything, but company policy stated that the conductor could not stop the train without personally verifying the problem, so both rushed toward Coach 1. The train was still running at 200 kilometers per hour, and vibrations were increasing. By the time they reached Coach 1, the train had already traveled 3 kilometers and was approaching a dangerous section where the tracks split. The broken wheel piece was still hanging under the train, scraping along the track. When the train crossed the first switch point, the broken wheel struck the track lever. That impact changed the switch. Now the front of the train was on one track, while Coach 3 moved on to another. The train twisted violently, and Coach 3 slammed straight into a concrete bridge pillar. Half the bridge collapsed instantly. Coach 4 managed to avoid the falling bridge, but crashed into an embankment, killing 3 railway workers. Coaches 5 and 6 were crushed under 300 tons of concrete. Their height was reduced to just 6 inches. Coaches 7, 8, 9, and 10 slammed into each other at full speed and folded like paper. Only the first 2 coaches, where George and his family were, remained intact. The front locomotive finally stopped 3 kilometers ahead. The drivers felt a jolt when Coach 3 hit the bridge, but they had no idea that total destruction was happening behind them. Nearby lay a small town called Eschede. When residents heard the massive explosion, they rushed to the site. What they saw would stay with them forever: twisted metal, broken coaches, flames, and injured passengers screaming for help. Some people were trapped under the bridge debris. Some were pinned inside their seats. The pressure-proof windows were so strong that even rescuers could barely break them. More than 1,000 rescue workers arrived. Ambulances, military doctors, and even 40 doctors from a nearby medical conference ran to help. But by then, the tragedy had already unfolded. A total of 101 people died. 88 were seriously injured, and nearly 100 suffered minor injuries. Passengers in the first 2 coaches survived. Germany's high-speed trains, once considered the safest in the world, had suffered a disaster that shocked not only Germany, but also every country operating high-speed rail, France, Italy, and even Japan. Investigators studied the site carefully. At first, they thought a vehicle may have been on the tracks, but when they examined the steel piece that ripped through Coach 1, the truth became clear. Logs showed that the very same wheel had reported a flat spot 8 times before, but it had never been replaced. Crack detection machines were available, but inspections were still done with handheld torches. The company claimed the machines gave too many false alarms. In 1992, a research organization called Fraunhofer had issued a warning about resilient wheels. In 1997, the Hanover Tram Company warned again. Both warnings were ignored. Engineers later explained that ice wheels rotated 500,000 times every day at high speed. With every rotation, the steel compressed and expanded slightly, causing fatigue cracks. And because of the rubber layer, vibrations were absorbed, so no one realized the wheels were cracking from inside. Finally, on June 3, 1998, one wheel broke. And a single broken wheel caused one of the deadliest high-speed train accidents in history. The Eschede disaster is still considered one of the worst train accidents ever recorded. After the crash, all resilient wheels were removed and replaced with monoblock wheels. Bridges near switches were relocated to prevent future accidents. Pressure-proof windows were redesigned so rescuers could break them easily during emergencies. Even today, the Eschede disaster is taught in German railway training centers as a major lesson. Monoblock wheels may be more expensive and time-consuming to maintain, but at high speeds, a single-piece steel wheel is far less likely to break, and vibrations serve as a warning signal that maintenance is needed. Thanks all viewers for their support. See you again in another amazing video.